Welcome to lecture 27. Today we are starting a new topic which is on GPS surveying. So, in the introductory part of the GPS surveying, this lecture will cover the importance, what GPS is doing as far as the mapping is concerned, and what are the different components along with their utility. So, let us begin with this lecture. Positioning or location of any object is very important to us. If we look at the history, prehistoric times, when man was a hunter, used to go to the jungle, to forest area. Sometimes the human being was lost in the jungle and wanted to go to the next location, but since the person was lost, so he was not able to identify the location, and the basic question in the mind was मैं कहाँ हूँ, किधर जा रहा हूँ. So that means it was totally unknown that which direction I am going, whether I am going in the right direction or whether I will reach to my destination which I have planned. So that was the scenario when there was no other method to determine the location, but from that period to now recent period, there are many systems which have developed which can help us in identifying the location of object or location of the person on the earth surface. Whenever we are talking of the position or the location, several methods have been developed in the past. Using the star constellation, you can find out certain coordinates. So, they were using the sun elevation. So, they were all used by sailors when they were in the deep ocean. There was no other means except to use the sun and the star and find out the direction in which one has to move. But these systems could not be used during the night when the sky is covered with lot of clouds. So, it was a limitation of such kind of a systems. The modern systems, as the technology grow, what we have is we have radio based systems which called like LORAN, LORAN and DECA. They are used by the sailors, but they are effective near the coastal area only. They are not effective when they are in the middle of the sea, because these systems, they do not cover the whole world, and in the boat, in the ship, one is moving from one place to another. The accuracy also was another factor when you are using these devices. The satellite based positioning, when it was developed, then we found that this satellite based positioning can give us better results than the previous method, and we can find out the position of any object on the earth surface using the signals from the satellite. So, I will take the signal from the satellite and on the basis of that find out the position. It is a very fast method, it is very accurate method of determining the location of any point on the object, whether it is a daytime or night time. So, anytime, anywhere is the slogan when we are using satellite based positioning. So, it is a very useful, because we can determine our position anywhere on the earth and anytime. There is no limitation of the day and time. And this is a global system. Satellite based system is a global system because we can monitor we can catch the signals from those satellites anywhere on the globe. So, that was the advantage of the satellite based. So, if I give you a little background of this, actually this GPS, global positioning system device, it is developed and it is a very useful technology for navigation purpose, for surveying, for geodesy purpose. It was originally, global positioning system was created and funded by the US Department of Defense, particularly for defense, army and military purpose this was created. So, DOD has put in a lot of efforts and the funding in order to launch the satellites so that one can get the correct positions from these satellites for defense and army purpose. So, initially in 70s we can find that these satellites were launched and the signals were received for military applications. Then, but in the early 80s the government made those systems available for civilian users. So, first GPS satellite was launched in 1978 and later on the one after another 24 satellites was achieved in 1994. So, lot of GPS satellites have been launched one after another to complete the constellation of the satellite. We need more number of satellites so that they are visible from the anywhere from the globe. So, the primary objective of the satellite based positioning was to get the position for US Army forces, but presently now the GPS signal, those signals are freely available to all the users anywhere on the globe. And once these signals are freely available to all the users around the globe, then number of civilian users have increased many folds in a very large number, and now the number is exceeding the military users, and very large number of applications not only in the field of mapping, not only in the field of civil engineering, but outside the domain of the civil engineering, anything which is related with the location has found the application of the GPS. So, we have different countries which have actually built their own systems of the GPS satellites. So, these satellite based systems, if we see the United Nations system, this is called Navigational GPS systems. Now, the Russian military system is known as the GLONASS, Global Navigation Satellite System, and this started in the year 1955 and then it became fully operational in the year 2011. Then came the Galileo. Galileo is the European Union and European Space Agency joint venture, started in year 2011 and then expected to be completed, this is 2019 at that time. So, one after another the constellation of the satellites were launched. Then there was a video navigation system, Compass. It was the Chinese navigation system, and this was actually it started in 2011. Then there is an Indian system, Indian Regional Navigational System called Gagan system, and this is a satellite based navigation augmentation. It was augmenting the existing systems. So, what is GPS? What is Global Positioning System? It is a worldwide radio navigation system, because it is using those waves, radios, that allows user to determine their exact location, and also in addition to location we can get velocity and the time also in all weather condition anywhere on the earth. As far as the mapping part is concerned, we require only location. We do not require the other parameters. Other parameters are required in the army. So, we are concerned with the geographical locations, three-dimensional location. So, these systems are giving us a very accurate position and precise time. Okay. This time is used by the military and the army on a continuous basis. So, continuously we are getting all this data from the device which we are going to use. So, what do we get from the GPS? We get the precise position of the data. So, when we are talking in civil engineering, in the mapping science, the precise position we will talk about here, the latitude, longitude and the altitude of the objects. Three things are there, and it defines the third dimension, three-dimensional coordinate. So, latitude and longitude are the x and y coordinates, the altitude of the object is the z coordinates of that, and the altitude here is not with respect to mean sea level as we see in our maps, but altitude is with respect to some datum, and that datum here is mostly WGS84 datum, which is called World Geodetic System. So, this is a system which is uniformly followed. So, this is called World Geodetic System. So, all our measurements are based on WGS84 system when we are using this GPS. It also provides accurate timing. So, what we are doing is we are taking help of the device and collecting the coordinates which are x, y and z coordinates, and we can use these coordinates directly into the GIS system, because geographical information system would require coordinate as the input, and then we can integrate this data along with the other data in the GIS. So, now if we look at the datums, because one is the mean sea level, another is the mathematical surface of the earth, and the third one is WGS 84 datum. So, it is very well shown in this diagram. Here we have the topographical surface, we have the ellipsoid surface and the geoid surface. So, we are here talking of the blue one, which is WGS 84 datum. This is the datum which we are using. So, there is a small difference as you can see in this diagram, and mathematically we can model that difference between the mean sea level and the WGS 84 datum. This is what it shows, the how you can convert from one datum to the another datum. So, there is a mathematical formulation which is shown here. This is my input, this is my output data. So, if I have the data collected at a datum and I want to convert it to the another datum, so I have to use some kind of a mathematical formulation, and many of the software, GPS based software, have this provision to convert the datum. There are various components of the GPS. So, let us understand these components and their role when we are using the GPS for various purpose. So, it has three well defined components or segments. We call this space segment, control segment and user segment. So, as the name itself is suggesting, space segment, we are talking of the satellites which are up in the space. So, normally it is a constellation of the 24 satellites, so that we can see them from anywhere on the globe. There is a control segment on the ground which will actually monitor the health of the satellites and see the all the other data. So, we have monitoring stations, control stations on the ground. And the third part is the user segment, where we have the receiver in our hand. So, I buy a receiver, that comes under the user segment. So, maybe we are more interested in the user segment, but little bit of knowledge of the space segment and control segment should also be there. So, let us see them one by one. In this diagram, I have shown all the three segments are there. So, space segment, where the satellites are continuously, 24 satellites are continuously moving in different orbits. Then we have a control segment on the ground. So, the data is received, there is a communication between the satellite and the control station directly, and then there is a user segment. So, we have a device which is the receiver device, and this is shown over here, handheld receiver for example. So, we have a receiver device, and this receiver device is directly now communicating with the space segment, the satellites which are visible from that particular location. So, all 24 satellites are not visible from a single location. So, whatever is visible from that particular station, from that particular point, the receiver will catch the signal. Now, what is the role of the space segment? Role of the space segment is where the satellites are actually moving, it will generate and transmits the code, and that codes is in various phases. So, we are using the carrier phase to transmit it, and there are navigational messages along with the carrier phase. So, there is a carrier phase, navigational messages, and the output is in the form of a P code, course acquisition code L1 and L2. So, this will you will learn in the subsequent slides. So, there is a transmission of the codes, there is a transmission of the navigational messages at the control station. So, this space segment basically it is constituting a constellation of the satellite, a large number of satellite, a group, a network of the satellites which will downlink the data including the code signals to that. And basic functions of these satellites would that they will receive the information, they will store the information and transmit to the control stations which are on the ground. These control stations are also well distributed. Then they will perform a limited data processing, because there is a small computer on, they have small on computer and limited processing of the data will be done. They will maintain very accurate timing. So, each of the satellite they are carrying the 2 cesium and 2 radium clocks are there, very highly accurate clocks are there. And this the information transmission is through the signal messages is there, and they will maneuver to the position in the space controlled by the control segment. So, this is how the satellites, GPS satellites would look like. You can see in the right image, approximately the weight is given 2370 pounds, height 16.25, width 38.025 feet, design life is 10 years. So, this is the representative figure of the GPS satellite launch vehicle. Then the constellation. So, the 24 satellites are there. So, 21 is the navigational satellites and 3 are the active satellites, and they are orbiting the earth every 12 hours. So, one round of the earth is done in every 12 hours. There are 6 orbital planes. So, these 24 satellites and there are 6 orbital planes. So, in each orbital plane there are 4 satellites and they are equally spaced. So, they are 60° apart, so that there is no collision also between the satellites, and these satellites are continuously moving in those defined 6 orbital planes, and due to the rotation in the 6 orbital plane continuously, at anywhere you stand on the globe with the receiver, you can catch the signal from sometimes 4, sometimes more than 4 satellites usually. So, what happens is now out of the 24 satellites, the user will get between 5 to 8 satellites. This is just representative, it depends upon the location where you are standing, how many satellites are visible from the point. So, normally we get a good number of satellites if the visibility to the sky is there, if there is no obstruction. Then these 24 satellites in the space segment, they are orbiting 12,000 miles above the equator. So, they are at a great height, you can't see them, they are not visible to us. They are continuously moving and making 2 complete orbits in 24 hours. As I told you, 12 hours, 1 orbit is completed, and they are traveling with the speed roughly 7,000 miles an hour. So, very high speed they are moving around the globe, because they are at a very great height. So, they take 12 hours to complete that, and they are powered by the solar energy, because the rotation and other activity require the source of power. So, there is a solar energy and there is a battery on board, backup battery on board is also there. So, there is a small rocket boosters on each satellite which keep them flying into their correct path. As you can see in this diagram, that in the center is the earth, and around the earth, around the globe, the satellites are moving in different orbits at different orientations. So, there are 4 satellites in each of this orbital plane what you see, and each of the satellite, as I mentioned, they are carrying 4 atomic clocks, very highly accurate those clocks are there fitted. This is the complete path of the satellites and the orbit. If I show that on the 2-dimensional piece of paper, how the satellite is moving. So, this is that complete path. You can see the zigzag kind of a path. Zigzag is rotation in one direction and the rotation in the another direction is giving you this kind of a satellite in the orbit path. Then there is a control segment, another segment is there which is called control segment on the ground, and this control segment is producing the GPS time, it predicts the ephemeris of the satellites, and it is managing these space vehicles. It is monitoring the health of the satellites also and correcting the path. So, this is a control segment on the ground. You can see there are monitoring stations at different places, well distributed at different places, and then there is a GPS control station. Colorado Springs are there. This is a user with the receiver at the end and receiving the signals, and then these satellites are communicating with the control stations also. So, all those 24 satellites are continuously communicating with the control station. So, if you see on the world map where these stations are located, we have one station which is called master control station shown by the blue color here, and the other stations are monitoring stations and the ground based antenna for communication purpose. So, they are quite well distributed around the globe and communicating with the satellites which have been launched. This diagram is showing the orbital path of one satellite in 12 hours. So, this is the 0 hour, this is the 12 hour. So, this completes the one round of the earth, and another 12 hours it completes the another round of the earth. So, 24 hours it will complete the 2 circle of the entire earth. Now, there is a user segment, and it is basically this part which is more important to us, and this is the receiver part. You know, we have a receiver, and this receiver now is communicating with the satellites which have been launched. We are not communicating with the control stations, okay, the control segment. We are communicating directly with the space segment. So, this user segment will give us the navigation solution. It will also give us the surveying solution. So, here we are receiving the codes, we are getting the codes, carrier phase observation and navigational messages are giving, and that is converted into the position, velocity and time. And then ultimately we are using the processing software in order to determine the correct coordinates of the point. So, the user segment has a receiver unit. So, you have to buy that receiver unit which can give you a real time positioning data x, y and z coordinates. So, we have different type of receivers nowadays available in the market. We have the handheld radio receivers which will actually measure the incoming signals from the GPS satellites, and the travel time of the signal is multiplied by the speed of the light, so that we know the range, we know the distance between the two, between the satellite and the receiver. So, from the additional information on the satellite orbit, ephemeris and the velocity, the GPS receiver in our hand, you know, it can calculate its position through a process of what we call as the resection process. So, we have a user segment which is consisting of the receiver. So, as I told you, there are different types of receivers available in the market, lightweight from handheld receivers to the geodetic kind of a receivers, very costly, sophisticated. So, the handheld will not give you very high accuracy, and geodetic receivers are used for very high accurate work. So, depending upon the accuracy which is desired in our project, we like to buy that receiver and use that receiver for collecting the information from the ground. So, this is a view of the handheld receiver. For learning purpose, this is very good. For some of the application also, suppose we have to design a road which is 60 kilometer long road. So, this handheld receiver can give me fairly good accuracy. I do not have to go for a geodetic kind of, but if we have to establish the benchmark or if we have to precisely determine the distance between the 2 points on a river, because I have to design a bridge, maybe I will go for a geodetic kind of a receiver. So, this is a blow up of the handheld receiver. There are different components which have been explained here. So, one can see that at the bottom we have some functional buttons, but in the top we have the display devices. So, we can use those function buttons in order to see how many satellites are there at this particular point, what is the signal strength, then what are the coordinates, what is the height of that particular point. So, all that I can see on my screen. Then there is a small inbuilt computer also. So, I can do certain computation, I can store my data. So, all that, retrieve my data. So, all that facility is there in the handheld type of receiver. So, these receivers are not very expensive. You can keep in your pocket when you are actually traveling to the field. When you are going from one place to another, you can take it in your pocket. They are very convenient to carry. But geodetic type, they are heavy, they are little bulky, you need a tripod, they need some kind of a stability so that there is no vibration when you are working in that area. So, this, because this is heavy, you have to mount the receiver plate on a tripod, and there is a controller in the hand of the observer. But they give very precise, highly accurate data. That. Then there are navigational type of receivers where you have the circular plate which I showed you in the previous slide, which receives the signal. This is, you can mount on your backpack, and then there is a handheld controller in your hand. So, you can move that receiver in the field from one place to another place, and you can get a good accuracy. Actually, you can get up to 12-meter accuracy from this data. They are lightweight, they are portable, and they are less expensive compared to the geodetic type of the receiver. So, they are mostly used for resource mapping purpose, for navigational applications. We can use these receivers. Now, looking at the application, broader applications of these GPS, we have integrated, this GPS along with the total station devices. So, those who have background knowledge of geomatics engineering, they must have used total station equipment for taking the elevation, measuring the distance, measuring the angles. So, it gives you complete solution. So, the total station mainly works when there is a horizontal clearance, works very well, and then you can get the coordinates also from this device. But if you do not have horizontal clearance, and if you have vertical clearance when you are working out, then the vertical clearance you can use the GPS device very well. So, there is a combination nowadays, the combination of GPS and total station. Instead of carrying two equipment, we are taking one single equipment, and this is called a smart station. So, this smart station is a very, very useful device. When we are working in the field and trying to collect the data, we are using the capabilities of the two instruments. One is the total station at the bottom and the GPS device at the top. So, wherever, when we are working in the field and we like to collect the three-dimensional coordinates data, whenever there is a horizontal clearance and GPS is not working because of the obstruction of the high-rise buildings, or you are working under a tunnel, or maybe in a forested area. So, wherever the signals are obstructed from those satellites, you will not get the very precise coordinates. So, in that case, we can take the help of total station device, but where the total station fails, where there is no horizontal clearance, suppose you are working in a crowded street, crowded area, then you may not have a horizontal clearance. You can work with the help of the GPS device which is available on that. So, one single equipment will serve both the purpose, and your work will be much faster as compared to carrying two instruments and working them independently. Now, these GPS are available nowadays in different gadgets and different devices also. For example, lot of people in addition to their mobile phone, they have the watches where the GPS is fitted. But this GPS will give you very crude reading as compared to the GPS which we are using in geomatics engineering, because we want quite precise, accurate data from those devices. So, the devices which we are using in geomatics engineering, actually they are much accurate. So, if you look at the applications, what are the different applications? Very large number of applications outside the domain of civil engineering, wherever the location is important. This has a wonderful applications in that, whether it is the home delivery of a particular or it is the emergency situation is there. So, wherever it is related with the location, then this particular device is useful. Navigation purpose, you must have seen in the vehicle also, this is a very useful when you are moving from one place to another. Then for navigational purpose it is useful. Tracking, you can track the movement of cattle, movement of the people, movement of the things, movement of your truck, movement of your car. So, that can be done. Mapping purpose, so when we are creating the different kind of thematic maps, then this is a very useful instrument, because nowadays in modern geomatics engineering we require coordinate systems in order to carry out the entire mapping work. So, this is very useful. We can get the correct timing also with the help of this device. There are a lot of advantages when we are using this particular device. So, unlike conventional surveying procedure, you do not require the intervisibility between the points. So, in surveying, when we are doing the survey and collecting the data with those conventional equipment, there should be intervisibility, connectivity between those points, but they are independent observations. The intervisibility may not be required when you are taking the observations. The second biggest advantage is the weather conditions. So, it is independent of the weather conditions. You can take observation all 24 hours in a day. You can use the same field and data reduction procedure, which is independent of the network shape or geometry. When you are working in the conventional, you have to take care of the shape of the figure which is made here. This is a very efficient, more flexible and less time consuming. When you are working in the field with one single device, you can actually cover a much larger area. You are getting a very high accuracy. You can create a 3D model, and the best is anywhere, anytime you can collect the data with the little effort at a global basis. So, this is all about this lecture. Thank you very much.